Today is December 1st, 2011. This is AP Statistics at Berkeley High School. Okay.
Nice to meet you.
We spent the last 3 days talking about sampling distributions. I want to talk today in section 7.2 about one particular kind of sampling distribution known as the distribution of sample proportions. That's where we're at. Okay? What we're going to do is we're going to find out some very particular salient facts about how the mean and the standard deviation of the distribution of sampling proportion looks. We're going to talk about some conditions on which we can use these rules, and we're going to calculate some probabilities because we use low probabilities as evidence against a claim of fact. All right, so let's start with this idea. We know that if given a population, we can draw repeated samples from that population. We can look at, amongst the individuals in a population, variables that are either quantitative or categorical. Today, we're only going to focus on variables that are categorical, like, is it raining today? Population is of all days. Is it raining today? Is a yes or no question. Population of our Berkeley High School students, maybe I ask the question, are you right-handed? It's a categorical variable. We're only going to focus on categorical variables today. So, let's talk about this question. We're looking at a simple random sample of Reese's Pieces. And we're going to look at what proportion of them are orange. Let's consider doing many, many samples of Reese's Pieces and looking at, again and again, what proportion of them are orange. Let's make an assumption. Let's start with an assumption. What would happen if exactly 45% of all Reese's Pieces were orange? Reese's. What?
Reese's Pieces.
No, it's not. But it's not. It's so annoying.
Reese's. Reese.
Leave us alone. If you're going to say it some way, tomato.
No, but this is a name. It's different than
Reese's Pieces.
It's a name. It's
Reese's Pieces.
It's pieces.
Wait. Are you saying without the apostrophe it's pronounced Reese's? And with the apostrophe it's still Reese's?
Reese.
Good point.
All right. We're off the rails. Okay. So, imagine if you will, please. Off the rails. Imagine if you will, please, again, what if I made an assumption that 45% of all of these candies are orange? Okay? Imagine, I look at my student Sam.
It's not your thing that's in me that I would think so.
No, all right. I do repeated samples of this candy with the assumption of a 45% proportion of orange. But I also do it the same, I do it again assuming 15% of them are orange. What do you notice in this first one? This dot plot of repeated samples with the assumption of 45% orange. Hey, take a look where that little red arrow is. Where's the center of all those dots, of all those p hats? About 45%. What if we did it with the assumption that 50% of them are? Wait, is that right?
You just doubled your sample size.
Oh, this is about doubling sample size. Okay. So, in both of these draws, we're assuming 45% orange. But we went from 25 candies apiece, found their proportion, another 25 found their proportion, and get this dot plot, which spreads from all the way down to 10% to all the way up to 70%. But what happens when I double my sample size? These dots don't go all the way to 10% anymore. The lowest is about 24%. The highest is about 65%. What happened to all of those dots from a sample size of 25 to a sample size of 50?
Closer to the mean.
They get closer to the mean. We have a V word that describes variability or variation. There is less variation in the p-hats when we had a larger sample size. What about the centers? What about the centers of all those dots? They're both centered at the same place, around 45, aren't they? What about the shapes? How would you describe the shapes? Are they different? They're the same? Perhaps you might use the word normal, maybe? Could we say that both of these samples have a normal distribution? I think it's a fair assumption. Could we say that they're both centered at 0.45? Fair assumption. And lastly, would we say that the one with the larger sample have less variability?
Yes.
All right. Okay, here's the samples again. But this time, what happens when we've got 15 in our sample? Instead of, we're assuming that 15% of our orange is compared to 45% of orange. I see two things. One, they're still both centered at 0.15, where the assumption was. Two, the one on the left doesn't look quite normal anymore. It looks a little skew. But the one on the right looks pretty normal. All right, so what we're going to do, we're going to leave it off here. According to the schedule, we were supposed to have a quiz on this stuff tomorrow. That is obviously not going to happen. I'm okay with this on the recording. Yeah. All right. So we will finish up this lecture tomorrow. We are a day behind. All right. We'll deal with it. All right. All right.